Now we're asked to find the average rate of change of the function f of x equals x squared with respect to x from x equals 1.5 to x equals 2. Now, the average rate of change of a with respect to b is change in a divided by change in b. Whatever a and b happen to be, that's the definition of the rate of change. So the rate of change of f of x with respect to x, as opposed to the rate of change of a with respect to b, would be what? Instead of change in a, we would have change in f of x. Instead of change in b, we would have change in x. So average rate of change of f of x with respect to x, consistent with this definition, is change in f of x divided by change in x, which is denoted with the delta sign. Delta f of x means change in f of x. Delta x means change in x. So the average rate is going to be the change in f of x divided by the change in x. Okay, from x equals 1.5 to x equals 2, of course, delta x, the change in x, is 2 minus 1.5 equal to 0.5. To find the change in f of x, we'd better evaluate f of x at 1.5 and at 2. Well, f of 1.5 is 2.25, f of x being x squared, the square of 1.5 being 2.25, and f of 2 is 4, so that the change in the value of f of x is 4 minus 2.25, which equals 1.75. Therefore, the average rate that we defined down here and applied to the question of the average change of f of x with respect to x is change in f of x. 4 minus 2.25 is 1.75 divided by change in x. 2 minus 1.5 is 0.5. So that 1.75 divided by 0.5 is the average rate of change, and that is 3.5. Now, we can depict that rate of change on a graph. Okay? If we graph the 2 points, and I did this in class, I'm going to do it here again. Okay, we got the point corresponding to x equals 1.5. That's 1.5, 2.25. Got another point out here for f of 2. Well, that's 2, 4. Now, I asked in class, what are the obvious things we can do if we have these 2 points? And everybody pretty much said right away, and I'm glad I have you conditioned, that was very good, that we draw the triangle, the fundamental triangle with sides parallel to the axes. I said the fundamental triangle. There are 2 that you could draw. You could have drawn it up and over like this. So you draw one of the 2 fundamental triangles, and it doesn't matter which one. So what can you find now that you've got this triangle? Well, the first thing you can easily find is this side and this side. This side is going to be 4 minus 2.25 equals 1.75. This side is 2 minus 1.5 equals 0.5. Okay, now that we found those sides, what can we find? And I posed the question. The first answer I got was, well, you can square these 2 sides and take the square root and all that stuff and get the length of this side, or the distance between the points, using the Pythagorean theorem. And that was a wonderful answer. That's one of the things you can do. And another thing you can do, and the second thing I got is, well, you can find the midpoint. Well, yeah, absolutely. You don't need these 2 sides to find the midpoint. As a matter of fact, you just average the 1.5 and the 2, and you average the 2.25 and the 4, and you have the coordinates of your midpoint. And I said, well, what else can you do? And I was glad that we got those 2, because they weren't the ones I was looking for, but I wanted to kind of reinforce what we get when we make this triangle. And the answer I got, well, you can find the slope. Okay, well, people knew that, and it seems that everybody was pretty well on top of that. Again, that made me fairly happy. Okay, the 1.75 is the rise, the 0.5 is the run, and the slope is rise divided by run. Okay, so, well, we did all that over here, and exactly the same thing. I didn't label the points because this triangle is a little smaller than that one. But the slope is, well, 4 minus, the 1.75 here is the rise, the 0.5 is the run, slope is the rise divided by the run, 1.75 over 0.5, which is 3.5. Now you notice that the calculation we have with the slope and the calculation of the rise and the run completely mimics the change in f of x divided by the change in x. Now, why should that be? Well, it's pretty clear that the change in x is from 1.5 to 2, and that is going to be the run, excuse me, corresponding to the triangle with these points. Okay, that's the run between this point and this point. And the rise is the change in your y value. And the y value is the value of f of x. F of x is, you have y equals f of x. So that the change in f of x is the rise between these 2 points. So we can identify the calculation of the average rate of change of the function with the calculation of the slope between the 2 points. So we have rise is a change in f of x, run is change in x. So rise over run is change in f of x divided by change in x, which is the average rate of change of f of x with respect to x. So the slope is equal to the average rate of change, etc. Now this is an extremely important idea for those of you who might well have a calculus course, at least an applied calculus course, in your future. And if you do a really good job in this course, you should be reasonably well prepared for that course, although you might want to take the pre-calculus, which has the same material as this course, but at a little more rigorous level, a little better preparation for calculus. But this whole idea of the average rate of change and rates of change and how they relate to the graphs and the slopes and so forth is very, very fundamental to the calculus. It's also very important for applications prior to calculus. So it's really good stuff, and it's stuff you really want to understand.